Hello, this is RC Jim. Well, today I've got a nice little comparison for you. I want to look at the difference between electric and nitro motors. Yeah, so I think about it, this particular plane here, you can see it's been through the works. I originally bought this back in the mid-1990s and flew it with my two boys as they were growing up. And it has been through an awful lot. But I still have it. I continue to repair it. And at the moment, I'm going from what used to be one of these up front to one of those up front. And you might wonder, well, why go to all of that bother? Well, that's what we want to talk about today. Now, as you think about electric motors, it's not for everybody. There are some distinct advantages to the good old nitro motors. And still have a couple of them, you know. But I've also decided to go electric, and I've got some reasons for that. I want to go through those things today, and I hope it'll be helpful to you. So let's begin by having a look at what's involved in the two. Well, here we've got the gear that would be involved in these two choices. So, on one hand, we've got the electric motor. It is powered by an ESC, which controls it. Power to the ESC and the motor, you know, it's coming from a battery. Of course, you got your receiver, and naturally you have a prop. Okay, on the other hand, as you think about the nitro situation, you've got a nitro motor. This particular one is a OS Max 46, about a 1.4 horsepower. Used to be on this particular plane here, sitting right up in there, and did a great job. Loved it. Still works great and all the rest of it. So that's the 46. And of course it gets fueled with a fuel tank. So instead of a battery and ESC, you've got a fuel tank in there. Okay, so comparing that with that. Of course, as it has an electric receiver for the radio, it still needs a battery. So I've got this little 1S, actually it's a 2S. Battery that could be used for that. It doesn't take much, but nonetheless it does need something to power the receiver. And naturally, it has a prop. So, what are the pros and cons? Why am I going to this compared to that? And why are some guys in our club still dedicated to these guys? Well, a number of reasons for it. First off, as you think about the electric motor, it's just extremely simple. You've got an electric motor, it's brushless, so there's not much in there to wear out. You don't have to mess around as far as starting with needing something to spin the propeller and having the power onto the glow plug and adjusting mixture and fueling it up and all that type of thing. Yeah, you still have to charge the battery, but nonetheless, it's pretty simple. It's also very clean. I think about the nitro motor. I mean, it's going to be spitting out castor oil or whatever synthetic oil you might be using. You'll be running a little bit on the rich side, so it's going to be spitting out here. The propeller is going to be blowing that back on the plane. And just from the look of this motor, you can tell that, yeah, it's not the cleanest thing in the world, and that's because of the stuff that's, it does. This is a nice clean situation. Relatively quiet. You still get the noise of the propeller and a little bit of whine from the motor, but relatively quiet compared to the glow fuel motor, and especially compared to a petrol motor, way quieter than that. So that's kind of a nice thing. With the glow fuel motor, you got a piston going up and down. Well, it's got a counterbalance down in here, and nonetheless there is a bit of vibration that the motor itself generates. Either case, you'd have a potential vibration coming from a prop if it's slightly out of balance, but in general the electric motor is going to be more vibration free. And of course it is cheap to operate. So it doesn't cost very much at all to charge up a battery. But as you think about the glow fuel motor, that glow fuel is getting pretty expensive these days. So that's a consideration as well. So, case closed? Definitely go with electric? Well, not necessarily. As you think about a glow fuel engine, you're talking about a real motor. You know, it's got a real piston that goes up and down, and it makes real noise like a motor does. You know, it seems like the real thing as compared to the electric motor being something sort of artificial. This motor is really powerful. You know, nearly a 1.5 horsepower out of this little thing that I'm holding in the palm of my hand. You know, that is pretty amazing. And it spins a really high RPM. It allows you to use a smaller length of prop because of the higher RPM and the power that it has to push, you know, a rather hefty prop through the air. This can do that. Whereas with the electric motors, we tend to go with larger props, in part because the RPMs tend to be a bit lower. They suit that situation. But also in part because the larger props are more efficient than smaller props, and we want to get as much as we can out of the motor. And so when it comes to ground clearance issues and things like that, generally the Nitro motor is going to be better. You get you know, it sounds like a real plane when it goes out there with the real engine sounds and all of that. Scale-like operation, you know, real planes, you know, the small ones, they will have piston engines, and so you got similar sort of things happening. And where the electric motor, I've got to plan, well, typically the day ahead, I've got to decide whether or not I'm flying, so I can get all my batteries charged up. It takes a fair amount of time to charge all the batteries, whereas with the Nitro motor, hey, just grab your container of fuel and off you go. Nothing else to do as far as stuff being done ahead of time. As you think of both of them have a bit of a fail-safe sort of situation. With a Nitro motor, because the motor and the radio are two totally separate systems. If the motor fails, you still got power to the radio, you can still control the airplane, you can do a dead stick landing, and you're okay. But they simulate the same thing with the electric ones, where the ESC has a programming mode in it, which is the standard way that it's set up, that it will cut the power when the battery gets down at a critically low level. It'll cut the power to the motor and just send power to the receiver. And that will allow you, I think, perhaps a minute or so to do a dead stick landing, which is way more time than what's needed to do that. They both have fail-safe sort of situations. With either choice, there are going to be some issues that you have. With the electric motor, depending on the system that you choose and the components of that system, you may need to limit the amount of time that you spend at full power on this, because this is going to draw whatever power it needs, and if you've got a great big prop on that and it really is demanding a lot of amps to make it run, depending on what you've chosen for your ESC and what the capacity is of the battery, potentially you could be heating things up, causing damage and things like that. With the Nitro engine, the sky is the limit. I suppose it's possible for it to overheat, but that's not likely in an airplane with the air blowing across it. Basically, if you want to run at full throttle constantly, there's nothing at all to worry about as compared to the electric setup, where melting things catching on fire, batteries getting damaged and stuff like that are all possibilities depending on how it's used. Okay, with the electric situation, just like with your car or anything else, eventually the battery is going to, lose its capabilities and things like that. Need to be replaced eventually. The motor itself, there's not a lot that happens to the motor as far as wear and tear. Bearings are a big thing to make sure that they're always good. And if it tends to get hot and things like that, potentially these permanent magnets in the motor can lose their magnetism. So it can tend to reduce in terms of power and things like that. But as you think about the Nitro motor, you get wear on the piston and the head, the sleeve and the cylinder. You've got bearings that can go bad, and especially if things sits around for a long time, you can get corrosion in the bearings and things like that. When they get knocked around, sometimes things like the needle valve, the needle valve can break off and be susceptible to damage, whereas with the electric motor things are more contained and there really isn't much to break off of it and stuff like that. And then with the electric plane, as far as the disadvantage, you don't just simply run the battery and run it dry. These batteries, they want to have a partial level of charge as they're stored. Now the critical storage would be long-term storage, where you're storing it for many months. But it's good practice to keep them partially charged when you finish flying, which means you don't use all of the power in the battery when you fly. Typically you'll fly until you get down to maybe 30% or so, and you target that sort of level as far as having a proper storage level of the battery when you finish. With a nitro plane, you can run the fuel dry. I mean, typically you don't want to do dead stick landings, so you probably won't be doing that. But whenever you get finished flying, you just simply pump the fuel out of the tank, and off you go, and there's nothing to worry about in terms of storage and things like that. But we have mentioned with the nitro motors, they tend to be messy. They make a lot of noise. If you're flying someplace close to homes and things like that, they won't be terribly happy with you using one of these, even with a muffler on it. As you think about putting this fuel tank up in here as compared to a battery, the weight of the battery is never going to change. But this position up here, where these things are, it's forward of where the center of gravity is on the plane. So if you've balanced it with a full tank of fuel, then as the time goes on, it's going to get tail heavy. If you balance with an empty tank of fuel, then when you start out, you're nose heavy. So it does affect the weight and balance somewhat. Not that I've ever had an issue with that, but nonetheless, technically that is a difference. With the nitro plane, you have a fuel tank that has a pickup in it that flops around depending on which position the plane is in. And the only real problem is when you're going straight down, then all of the fuel is in the bottom, and chances are that pickup can't get down there. Which is not a big deal as far as you don't need the power when you're going down, but keep in mind, if your nitro engine quits when you're in the air, it stops. You don't, well, most planes anyway, don't have an electric starter on board, and so if you happen to spend too much time going down with too low level of fuel, potentially your engine could quit. And of course, the electric engine doesn't care what direction it's pointed or anything like that. Makes no difference at all. In general, the electric motor is going to be much more dependable with regard to going when you want it to go and not quitting along the way. I've had numerous issues, from time to time, and when I say numerous, you probably fly 10 or 12 times before you have some sort of an issue. But, it depends on the heat that's in the motor and how rich you have the fuel and things like that as to, what you got the idle level set at and all of those sorts of things as to whether this thing keeps on going. Now, if you're really good at it and you're experienced and you do it all the right ways, it's probably, 90% good without having any sort of difficulties. And then the few little times where you do have a problem, you do a dead stick landing, you land, and that's fine. But as with real aircraft, with model aircraft, you got two times that are really critical that you don't want an engine failure. One is on takeoff and one is on landing. Now generally when you're taking off with a nitro engine, it's not too much of a problem because the thing is going flat chat, you've got it full throttle, and they'll tend to keep on going. But coming in on landing is an issue in that you're going to be backing off on the throttle and perhaps right back close to idle in many cases. And that's a time that it's rather susceptible to quit. Now, given that you're coming in on landing, you've probably got the field made and you can do it dead stick regardless, but nonetheless you might have a problem not being able to go around and some other issues. So I'd say less reliable with a nitro engine in terms of problems with the engine deciding to stop for whatever reason at times that you don't want it to. Okay, so I'd say that also means that it's a higher skill level that's needed to manage properly a nitro engine as compared to an electric motor. Now, having said that, a lot of things that we do, we like to do it the hard way because we enjoy the challenge. So that might not necessarily be a problem. Okay, now let's think about failure modes for each of these as to what might cause a problem. Okay, for the electric plane, the battery running flat. Okay, you're going to have a problem there. And of course you got the fail-safe mode on the receiver, but potentially if you just got one battery and there's some sort of failure in the batteries, the electric circuitry or whatever fails, it could mean that the plane just totally loses control and, packs it in. So that's one failure mode for the electric. Problem with the battery, either it runs flat or there's damage to the battery, it quits operating the way that it ought to. Second failure mode for the electric plane would be the failure of the ESC. So this might melt, and especially, like, let's say we've got a 50 amp motor on there, and if I was to pick, say, a 30 amp ESC, this one's 65, so quite safe, but nonetheless, if I've gone too small on the ESC, potentially that could melt. And as with any electronic components, there could be other things that happen to this, maybe either rough landing or crash or something like that. Something gets damaged inside there, and that stops operating the way that it should. So you got a potential problem with that. That's another failure mode. The motor itself, say you run it too hard and it's drawing too many amps because you put too big of a prop on it and you're running it at high levels of throttle. You could potentially melt the windings in the motor. That could cause it to short. It might cause a fire. It might cause the motor to quit. So you got potential problems as far as that is concerned. And of course, any of the electric components here, you're talking about very high current that's running through this entire electric system here. And with high current, you got potentially significant issues with regard to fire and damage and even explosion as you think about the battery. And just one last little one that's a failure mode with the electric one. If you notice with this one, we've got a lock nut on the end of it there. So you got two nuts on the end, okay, with the prop going in here. That lock nut has got a good purpose, and that is that with an electric motor, you can program the ESC such that it puts on the brake. And depending on what ESC and combination you've got, that might just simply be brake on or brake off. But some of them have the level of braking, and with any of them, at the very high level of braking, you're talking about a really quick stop. When you take the power off, you bring the throttle down to zero, it's bang, it just stops straight away. And that amount of reverse torque on this motor, with that prop spinning around with all the momentum of the prop, just clamp it shut straight away, that potentially could cause the prop to spin right off. Okay, so you can adjust that, and typically the way it's set up with the standard settings, it's not on and the prop is allowed to freewheel. But nonetheless, that is a failure mode. With anything electric, as we'd be familiar with the good old days with the nitro motors, anything electric, you can have problems with connectors and stuff like that. So just like in the with any of these, with the servos and things like that, you can have connectors that come loose and fail in various ways. With an electric motor, you've got more electrical connections that potentially could fail, and you've got a number of connections that have very high current going through them, and they would be even more susceptible to failure. So, number of potential failure modes for the electric setup. Okay, what about failure modes for the nitro motor? Well, you run out of fuel. That could be one thing. The engine might quit due to, maybe you've adjusted the fuel mixture too lean, and typically you'll start it out with just a tiny bit rich, just 4 cycling with a 2-cycle motor, 4 cycling at the start, which is sort of hitting every other revolution. And then as it warms up and as it gets up there and the RPMs go up, then it goes into the 2 cycles in a mode. At least that's how I used to do it anyway, back in the good old days. But anyway, with inexperience, you might have that set wrong, and it might cause the motor to quit. The fuel pickup, losing contact with the fuel, so as we mentioned, going down especially could be a problem, or maybe something just sticks and the pickup's in the wrong place, or maybe even the pickup comes loose from the tank along the way. Okay, other fuel line connections might come loose, and so you don't get fuel to the engine. We have noted already that once the engine stops, if you're up in the air, that's it. And it's even a pain if you're out there getting ready to take off and you're sitting there idling, waiting for somebody, and then all of a sudden the engine dies on you, and you get to have a walk back to the pits again to restart it. Yeah, that happens too. Just thinking about the radio, you've got a receiver battery for the radio and this, but this will run for, a number of flights, depending on how big of a battery you have. You should be able to run all day, with this one particular battery. But it might be something that you're not thinking about checking, and you don't realize that it's going flat, and all of a sudden you got no radio. Plenty of power on the engine, but no way to control it, and off your plane goes, So that's a potential failure mode as well with that. Now, what about extra bits that you need to be able to do these things? Because in either case, whether we're using electric or whether we're using nitro, there's going to be extra stuff that you tend to have. So as you think about that, I go around with a case with a whole bunch of stuff in it. Got a whole bunch of batteries. I've got a whole bunch of connectors and things like that. I've got a charger, and of course the radio. Lots of stuff that goes along with the electric thing. Well, what's the situation for the nitro plane? Well, for the nitro plane, you're going to need some way to spin the prop. Large ones, they will tend to spin them by hand. I've damaged my hands that many times as a kid, not really keen on that. So for a lot of people, they'll use a 12-volt starter that they push onto the end of it. And for a 12-volt starter, it means you also need a 12-volt gel cell or something to power the starter. So you have to have that little starter. You have to have a 12-volt battery to go along with it. You need something to be able to get fuel in the fuel tank, and so that might be a hand pump with a crank on it. Might be an electric pump that you might have to pump fuel into the fuel tank. Either case, if you're using rechargeable batteries, then you need a battery charger to be able to charge the batteries. Let's see, fuel pump, electric starter, charger for the receiver battery. So that's pretty it as far as the extra bits for the nitro plane. And as I showed you with this, with the electric planes, typically we will have multiple batteries to allow us to do however many flights that we want to do in a particular morning. I say morning because we like the low wind conditions and all of that. But if I want to do, say, 3 flights of this plane, that means that I'll bring along 3 batteries, you know. So, you know, there's 3 batteries, and these aren't all ones that I use for this particular one, but nonetheless, they're all roughly the right size. And then with another plane that I've got, I'll have, you know, more batteries for that plane, and you end up with a whole bunch of batteries, okay? And you need all of that. And we already mentioned that you need a charger. So with the charger, there's different ones that are available, but this is the S1200 Spectrum charger. I like this one because it operates off of 12 volts. So I got a 12 volt power supply here in the garage that I can use to power it, to charge the batteries. But also if I'm at the field and for whatever reason I want to charge batteries as I go, which I used to do when I first got started with the electrics. I didn't have enough batteries, and so the minute I finished with one, I would plug this into the car and get one going while I'm up flying with another one, and usually I'd get a couple of flights in and then go back and get the battery that was charging and put another one on and so forth. So anyway, you need a charger. Power supply, I already mentioned that. If you want to adjust the ESC, depending on what type you have, you might need a programming card. And I'm not seeing mine right offhand. It's around here someplace. But anyway, to change the programming on it, if you got a Spectrum with the newer NX transmitter, you can do it right on the transmitter without too much difficulty. But for most of these, you have a programming card that if you want to do something like to turn the brake on or reverse the motor or various things like that, it takes a special little card that you plug into the ESC to do that. You'll want a capacity meter. So this is a GT Power capacity meter that you plug in the battery that shows you the level of charge and all of that. So you have to have one of those. That's important to be able to check that after each flight. And I guess that's about it. Multiple batteries we already mentioned. Okay, now what sort of risks are there with each of these with regard to the various choices that you make as you're deciding to get going? Well, with the electric one, the key thing is that the components are all compatible. So the current draw is going to be determined by the motor and the prop. So this is something that's very different as compared to the Nitro motor. Nitro motor, there'll be a prop that it's most efficient at, and basically with any sort of piston engine like this, there's going to be one given RPM where it has the capability of developing the maximum horsepower. So wide open throttle at a particular RPM, that'll be the maximum power. And so you can play around with different props to try and hit that RPM and get the maximum power out of it. But if you make the wrong choice and you put on too big of a prop, it just runs a little bit slower and a little bit, it's less efficient as far as the motor is concerned. Maybe more efficient as far as the prop is concerned. But nonetheless, minor consequences. Too small a prop, it just means the motor spins faster. I suppose if you go real small, you might wreck the motor from going over revving it. But generally, with a Nitro plane, there's very minimal consequences in terms of prop selection. Whereas with an electric plane, it's absolutely vital, and that if you put too big of a prop on it, and believe it or not, that's not too big, but if you put too big of a prop on it, then it's going to draw more current than what it's rated for, and potentially could melt the motor. And then, of course, just as you need to make sure that you got the right prop for the motor to not draw too much current, then you want to make sure that the other components of the system are also compatible to where your maximum current that the motor is going to draw is going to be something that the ESC can handle and something that the battery can handle. Neither of these are going to keep it from happening. So if the motor decides to draw more current than what it should be, it will get it. And the only question is, what is going to get damaged? Will it be the battery that goes first, the ESC, or the motor? Those are critical issues with regard to an electric system. So thinking especially about the props, we're changing props all the time. You might break one and you look for one to put on there or whatever, but it's really critical with an electric motor that you get the right prop. And we have another video that we're going to be doing shortly, where we're going to be talking about prop selection for particular motors and be able to work that out. Okay, for the Nitro motors, in terms of negative consequences from wrong decisions, probably the fuel mix is one of the biggest ones. So you choose what sort of percentage nitro you want. Of course, the more nitro that's into the fuel, the harder it is on the engine. The higher percentage of oil, the easier it is on the engine. You got choices between castor oil and synthetic oils and various things like that. And a lot of guys like to do up their own mixes. Well, you get that wrong, you could do damage to the engine. So you got that particular matter. And then choices like as far as starting system, if you decide to flick start it, well, potential damage to your fingers. But apart from that, with a Nitro motor, it's pretty straightforward with regard to choices you make. Well, I trust that this has been helpful to you in comparing the two. And if you got other questions or wonders about various things about either system, just pop them into the comment section below, and we'll be happy to answer those for you.